Hey everyone, welcome back. And in this lesson, we're going to continue what we were talking about in the last video, which was solving square roots by hand. So what we're going to do in this lesson is we're going to do just a few more examples. Last time we did two examples. I believe that was the square root of 256 and the square root of 361, if I'm correct, were the two that we were trying to calculate in the last lesson. And so what we're going to do in this video is we're just going to continue with a few more examples of that, and then you guys will have an assignment on trying to compute some square roots by hand. Now, what I suggest when it comes time for the assignment is try doing it by hand, but since it's not an overly complicated thing to type into a calculator or into Google, just check your answer, see if you've done it right, and if not, try and go back and retrace your steps, right? Because if you're looking up the answer or typing it into a calculator and just writing down that final answer, that's not really going to help you in the long run, right? So try working through it, and if that doesn't give you the right answer, try and backtrack. You can rewatch the last lesson or this one and see if you can spot maybe where you've gone wrong. But yeah, what I recommend with the assignment is, because it's not overly complicated math that we're doing, and it's really not going to be much more than just me asking you to calculate a few square roots, check your answer. And what I'm also thinking for the assignment is I might put on a couple of the square roots that we've already covered in the lesson, just for you to try them one more time, and you have in your notes or in these lessons what the answer is supposed to be and how to get there. So for example, I might put one of these two on there, or one of the ones that we do today could make up a portion of your assignment. So with that in mind, we'll go through these examples today, take note of them, and then when it comes time for the assignment, some of them might be exact copies of the ones that we do here, just for you to try it again. And if you get stuck somewhere, revisit your notes or revisit the lesson and see if you can figure out where you've done something differently. All right, because this stuff, it's got some similarities to long division, but we don't want to get carried away with that, because there are some differences as well, and we don't want to accidentally confuse the steps of finding the square root with dividing one number by another, right? So that said, let's begin. We'll start with, if you want a title, you could say Solving Square Roots Manually Continued or something like that. It's really just practice problems today. So this is going to be the first one that we do today, is the square root of 625. Alright, so what we're going to do is we'll set it up the same way that we set them up before. So remember, we're going to keep that square root sign looking the way it was. So we've got the 6 there, and then we've got 25 like so. And so the first thing that we want to do with this setup is we want to section off the number. We want to chop it up into pairs of numbers. So 2 numbers and then a comma, 2 numbers and then a comma. But remember, we start from the right side. So you'll notice that there's a difference, right? If I start from the left side with putting those commas in, don't write this down. If I start from the left side putting those commas in, we'd end up with 62, comma, and then the 5 by itself. You want to make sure you're starting from the right side, count over 2 numbers, so we've got the 5 and the 2, and then we'll put our comma there. If you don't like a comma, I suppose it would be fine to put like a line straight down, but then you might confuse it with a 1. So if you don't like the comma for some reason, see if you can figure out something else that works for you, like a dotted line or something. But yeah, I tend to put a comma, so that's what I'll continue doing. And so once you've separated the numbers, we've got the 2 digits there, comma, and then we only have 1 digit left over, so that's fine. Now we're ready to start the problem. Now before, when we did the first couple of examples for this thing, I sort of just threw a 1 over here. Don't write this down. I sort of just threw a 1 over on this side and then didn't really explain why it was there. So if you remember from last lesson, you have some number under there, right? You get a number on top. We're going to ignore the fact that we had a 1 here before, but you get a number on top, and then you bring it down and you double it, right? But then as you double it, you also move it over from the ones place into the tens place. So if you got a number like 3 on top, then as you bring it down and you double it, it becomes a 6, but it also moves into the tens place, right? So instead of having just a 6, it would become 60 something, and then we just need to find the digit that goes in that ones place. So the way that I would suggest that you think about this is don't just automatically throw a 1 down here. Think of it as every time you have to calculate the square root, you're just trying to fill in the ones place, right? Because for the couple of examples that we did last time, we had a 1 here and a 1 up there, which worked out nicely. But then when we brought it down over here and we doubled it, we had a 2 and then that empty ones place. And if we had a longer number, we went through a second step and had to bring down another number and double it, you would take that number and shift it over and still be left with an empty ones place. You could have like I don't know, if the number that you filled in here happened to be a 2, and then you put a 2 up there, we'll get to that stuff eventually, but basically the point I'm trying to get across is that every time you go through this process of finding a number that goes over here and a number that goes up top, every time that you bring that number down and double it, you shift everything over one spot. So if you had a 2-digit number, then, or if you had a 2-digit number up here, when you bring it down and double it, it'll become a 3-digit number where you have that empty ones place. So you'll see what I mean when we go through more examples of this. Today we're going to stick, I think, to examples that were the same length as last time, but if we have time we can try and go through one more. Otherwise, in another video I'll explain how a more complicated example of this would work. But so ignore that 1 and that 1. If you've written that stuff down, get rid of it. We don't need any of that right now. Or just rewrite the square root. So the way I want you to think of this is I want you to think of this space that we need to fill in as an empty ones place. And we have an empty space up there that needs to be filled as well. And so the idea is we want to find some number that we could put here and up there and multiply those two together to get either 6 or something smaller than 6, right? Because we're only dealing with the 6 right now because that's the first group before the comma. So we're just dealing with that 6 right now. So we want two numbers that can be multiplied together that equal 6 or less, and more precisely than two numbers, two identical numbers. The same number that I put here has to be the number that I put there. So for this first step, we're effectively just finding a number that when you square it is either equal to 6 or smaller than 6. Alright, so we start off by just listing off some of the first few perfect squares, and we'll see what works for us. So 1 squared, that's 1 times 1 is equal to 1. 2 squared is 2 times 2, that's equal to 4. 3 squared, 3 times 2, not 3 times 2, 3 times 3, that's equal to 9. So 9 is too big for what we want over here, right? So we started with 1 squared, that works out just fine, but 2 squared also fits the bill. 3 squared overshoots our target, right? Our target is 6 or smaller, so 3 squared is too big. So we're going to have to backtrack one step. 1 squared fits the bill, but it's too small, so we use this 2 squared, because this 4 gets us as close to 6 as we possibly can get without overshooting. The next number in our sequence would have been 9, which doesn't work. So because 4 is the number that works for us, that came from 2 squared, right? So the number that we're actually squaring is the important part. So because it's 2 squared, we put a 2 over here, and we put a 2 up top. Alright, so every time that you have this underscore type thing, I'm indicating that you have to put the same number here and the same number there. So we put a 2 over here on the side, and we put a 2 up top. Now, whatever you have over here on the side, and what you have up on top, those two need to be multiplied together. So we multiply those two together, and that product, that answer to that multiplication question, is what we're going to subtract from 6. So in this case, we have a 2 on the side and a 2 up top. So we multiply those together. That's going to give us 2 times 2, or 2 squared, which is 4. So we put a 4 down here underneath the 6, and we subtract. So we go ahead and do that subtraction. That'll leave us with 6 minus 4 is 2. And then we're going to bring down the next pair of numbers. In this case, there is only one pair of numbers that we actually have to bring down. So we bring down the 2, and we bring down the 5. So now we turn this into 225. And I'll put that square root sign back. And so now what we want to do is we're going to take the number that we have up top. So right now that's just this 2 over here. And we're going to bring it down over here. And while we do that, we're also going to double it. Alright, so I'm going to get rid of those underscores because we don't need them anymore. So we take that 2 from over there, and then we double it, we bring it down over here, so that 2 times 2 is going to give us 4. But remember that we're moving that 4 over into the tens place, so it's not just 4, regular 4, it's 4 with a space beside it that we need to fill in with some number. So it's going to be 40 something. Alright, so now what we need to find is 40 something times something that equals 225 or is smaller than 225, right? So same idea as with division. We want to find a number that gets us as close as we can to the 225 target, or falls just a little bit short but not too much. So we could just test out a few numbers if you have forgotten how this works. So basically, whatever you have in the ones place, whatever you put beside this 4, is also what you're going to multiply that entire number by. So for example, if it was 41, you would multiply it by 1. If it was 42, you would multiply it by 2, and so on. Now, just eyeballing it, I know 42 times 2 is 84, which falls way short of 225. So let's try something bigger. Let's try something like 45 or 46 perhaps. Let's try 46 and see if that overshoots, and if it overshoots we backtrack, right? So if we are filling in a 6 there, then that means we have to multiply the entire thing by 6. So if we multiply that whole thing by 6, that would give us 46 times 6. 6 times 6 is 36. 6 times 4 is 24, plus 3 is 27. That overshoots our 225. So 6 isn't going to work, it's going to have to be smaller than 6. Now, let's try 45 times 5. Let's try filling in that gap right there with a 5. And the reason I'm feeling confident about the 5 is because our number over there ends in a 5. If you're multiplying two numbers together where the ones place for each number that you're multiplying is a 5, your final answer should have a 5 as the last digit as well. So that's giving me confidence that we'll get that as an answer. I say giving me confidence, I worked these out yesterday. So let's try filling in a 5 right there. So we had 40 something times something, and we're filling that in with a 5. So it's going to be 45 times 5. And if we go ahead and do that calculation, 45 times 5, 5 times 5 is 25, 5 times 4 is 20, plus 2 is 225 exactly. Alright, so that doesn't overshoot, so we can use 45, we can use the 5 as our sort of magic number. So 45 times 5 is equal to exactly 225. So that means I can fill in this space beside the 4 with a 5. And if I'm putting a 5 over here, I also need to put a 5 up top over there. So that's going to go above this group, this final pair of numbers, that 2 and 5. We're going to put it above the last digit, above the rightmost digit in that pair. So again, I know it looks a little bit weird that we have this little bit of a space here, but that's something we just kind of have to deal with the notation. So we've put a 5 here, we've put a 5 up top. Now, what we need to multiply together to figure out what goes under here is this entire 45 and that 5, which we've already done over here on the side. That's how we got this 5 over here was by experimenting with that multiplication. So we know 45 down here times 5 up there is going to equal 225. So I put 2, 2, 5, I subtract, and that's going to leave me with exactly 0. So we are done because we've got a 0 down there and we've got no more numbers to bring down. So that means that we can state our final answer by just reading off these digits from up top. So if we go ahead and do that, root 625, we can read off our answer from up there, is going to equal 25. Or, you know, negative 25, as we were talking a few days ago, but right now we just care about the number, right? Positive and negative signs are all that changes, but the actual number doesn't, so suffice it to say, just 25 as your answer. Alright, hopefully that's making sense. The process will hopefully get a little bit clearer as we do more examples, so we'll do at least one more, and hopefully 2 more, but I'm going to pick up the pace with the next one's kind of easy. So yeah, so we'll do the next one. You'll hopefully see that it's, hopefully you're starting to see the pattern already. But the next one is slightly easier perhaps, but it also has a little bit of a trap where you can sort of get stuck. It's a similar trap to where you can get stuck in a long division problem, so don't get too worked up if you see a problem like this. But I'm going to pick up the pace slightly, except for the spot where you could get stuck. So the next one we're going to do is the square root of 900. Alright, so we're going to start off just as we always do. We write our square root sign and our 900 underneath it. And now the first thing we want to do with the number is we want to section it off. So we take our 2 rightmost digits, that's going to be a group of numbers, and then we put a comma. And so then we've got this 9 by itself, and then we've got our pair of zeros over there on the side. So now, if we think about this as having an empty ones place over here, and an empty space up there, and we need to fill in both of those, we need to fill both of those in with the same number, such that when you multiply that number by itself, when you square that number, it equals what you have in your first group, which in this case is just a 9. So we need a number such that when you square it, you either get 9 or something smaller than 9. So once again, we go back to our handy-dandy list of squares. 1 squared, 2 squared, 3 squared, 4 squared. That should be enough. Now 1 squared, that's just 1 times 1, which equals 1. 2 squared, 2 times 2, that equals 4. 3 squared, 3 times 3 equals 9. 4 squared, 4 times 4 equals 16. So we just got a list of a few squares. These ones are all good to memorize. But we can see that we might not have even needed to do 4 squared equals 16. We can just sort of get rid of that one because we have that 3 squared equals 9 exactly. So that tells me that the number that I'm filling in here and here is the thing that I was squaring, which happens to be a 3 in this case. So I'm going to have a 3 over here, and I'm going to have a 3 up top above that 9. Now, the next thing I need to do is figure out what I'm subtracting from 9. And to get that, I take whatever I have on top, and I multiply it by whatever I have over here on the side. So we've got 3 times 3 equals 9. So I'm going to put a 9 down here, and we're going to subtract. So if we go ahead and subtract, we get 9 minus 9 equals 0. Alright, hopefully nothing too complicated so far. Here's the trap. In the previous questions, whenever we hit a 0, we happen to be finished, right? And in a division problem, sometimes you do that subtraction, it works out perfectly with the first couple of digits, and you end up with a 0 there, and some people stop the question prematurely, or they skip a step and they don't add in the right digits in their quotient and stuff. This is not the end of the problem. Yes, we have a 0 down here, but we still have more numbers to bring down. So, doesn't matter what you get over here. It could be a 0, doesn't have to be. You're still going to pull down that next group of numbers. You have to pull down the next group of numbers if you have one. So we pull down those zeros, so we've still just got the 0 under the root sign. Great. And we're going to take this 3 up top, we're going to pull it down, and double it. So as we do that, we get 3 times 2 is 6, but we're also going to move it over a spot. so that there's an empty ones place. So it's not 6, it's 60 something, and we need to figure out what the something is. So it could be 60, 61, 62, 63, whatever. And it's going to have to be 60 something multiplied by something, which we're going to fill in up there. So our target here is we've got 60 something on the left hand side, and we're going to be multiplying that by whatever we've put in the ones place here. So it's going to be 60 something 60 something times something, which has to either be equal to 0 or smaller than 0. Now, we're not going to be taking negative numbers here, so basically we need 60 something multiplied by the same number in the ones place here and here, that equals 0. And so the only thing that works, 61 times 1, that doesn't work, that would be 61. 62 times 2 doesn't work. So clearly going up isn't going to work because that's going to give us something bigger than 0. The only way we can get 0 by taking 60 something and multiplying it by something is if it happens to be 60 times 0. Remember, we're filling in the same digit in both places, so you can't have a 0 over here but like a 2 over there. So if you've got a 0 over there, you have to have a 0 over here. So now we know that it's got to be 60 times 0, which tells us that we're filling in a 0 over here, but we're also filling in a 0 up top over there. So we put in that 0 up top. I'm going to get rid of that underscore. I'm going to get rid of this underscore. To figure out what we're subtracting from here, it's going to be 60 times 0, which is equal to 0. So we subtract 0 from 0, and we get 0. Lots of zeros down here. And now we're done the problem because we've got a 0 down here, great, and we've got no more groups of numbers to bring down. We don't have another pair of 2 digits to pull down and do another calculation with. We've used up everything, and we've got a 0 down here. Everything's nice and neat and tidy, and now we can read off our final answer. The thing you have to be careful with is that you don't stop up here. You don't stop prematurely when you see that first 0 after the subtraction. Say, oh great, my answer's 3. No. Your answer's not 3. 3 squared would be 9, not 900. So that's why you got to be careful with when you get that 0 as your answer for that first one. It's not always going to work out that way, and you will have to pull down the next group of numbers if you have one. So we can just read off our answer to get our, from the top there, to get our solution, to get our square root of 900, which in this case happens to be 30. Just reading off those digits from the top. Alright, hopefully that makes sense. It's a slightly different problem from the last one just because, we had some extra zeros and stuff, but it's really not that different from the other questions. There's just that one little pitfall that you don't want to stop working on it a little bit too early because then you'll end up missing that 0. And if this was a much, much larger number, maybe the answer was supposed to be 301, but you skipped the 0 and you wrote 31 instead, right? So those are the kinds of things that you got to be watchful of, is that zeros can make all the difference sometimes. They can make or break a question for you. So yeah, this example isn't too different from the last one except from the zeros, and we'll do one more, just a little bit of extra practice, never hurt anybody. The next one we'll do is, this will be the last one for today, and then if we've got more time in the future, I'll do a more complicated one. But we're going to do the square root of 961. That's our last one for today. So, for this one, I'm going to go, again, a little bit faster for this one, but not too fast. So this one, we write that square root sign, we put our 961 underneath the root sign. Great. Now we have to section off this number starting from the right-hand side. So we start from over there, and we take the 2 rightmost digits, and that's a group. So we put a comma in between, and then we're left with just a 9 over here. So we don't have to do any more sectioning off with commas, and we're done the sectioning bit. Now we move on to dealing with, we've got an empty ones place over here, and an empty place up there that needs to be filled. What number can we put here and multiply them together to get 9 or smaller? That's the target. Basically, it's what number squared is going to be equal to 9 or smaller than 9. That's our target. Don't worry about this notation too much. That's less than sign, and if you put another line underneath it, that means less than or equal to. So what number squared is less than or equal to 9? That's the target. And again, we return to our handy-dandy list. 1 squared, 2 squared, 3 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9. Same as last time. So we got 3 squared is 9 exactly, so that means 3 is the magic number that fits the bill. So we put a 3 over here, and we put a 3 up top. I'm going to get rid of those placeholders. So we've got a 3 over on the left side, we've got a 3 up top. Those are the two numbers that we're multiplying together to put down here under the 9. So 3 times 3 is going to give us 9, so I put a 9 over here, and we subtract. We go ahead and do that subtraction. 9 minus 9 is 0. Here's a similar pitfall to the last question, is that we've got a 0 here, but we're not finished the problem. With the previous question, it might be a little bit easier to make a mistake, because even if you bring down the next two digits, you were still getting zeros over there, and people will sometimes look at that and be like, oh, well, I had 0, I did the next step, and I still have 0, maybe I'm actually just done the problem. This question, it's maybe a little bit less obvious, or maybe it's harder to fall for that trick, because we still have that 0 here. Somebody could be fooled into thinking we're done, but they would have very blatantly ignored the 6 and the 1 over there. And if they just bring those two numbers down, they'll see that they're most definitely not finished the problem yet. So sometimes you'll get the 0 here, sometimes you won't. Same thing with division, right? Sometimes you deal with just that first number of your dividend, and then you have your divisor, and you go ahead and you calculate that, and it gives you exactly 0 before you bring down the next number. So similar idea. But yeah, just don't fall for it if you've got an extra group, especially if that extra group is purely zeros. Don't fall for the trick of just, you know, forgetting to deal with it, because it'll give you the wrong answer. You'll be off by a factor of 10 or something if it's the last number, and your answer will just be plain wrong if you're dealing with a much larger number, just missing a 0 in the middle. So basically, long story short, be careful when you're dealing with zeros. But we got 9 minus 9 is 0. We bring down the next group, so we take that 61 and pull it down here. I'm going to make that look like a square root sign. Now we're going to take this 3 from up here. We're going to bring that down and double it as we do so. So we get 3 times 2 is 6, and we're going to move it over so that there's an empty ones place beside it. Now there's an empty place over here, and there's an empty place up there. So what we need, I'm going to get rid of this stuff, what we need now is 60 something times the same something that equals 61. That's what we need, that's the target. So if we did 60 times 0, where if we put a 0 here, we have to put a 0 there, that's going to give us 0. That's what we were getting last time. But that's not going to work this time, obviously, because we don't have zeros there. So let's go up 1. 61 times 1. Well, that was quick and easy. That gave us exactly what we needed. 61 times 1 gives us that target of 61 exactly. So that means I can fill in a 1 over here, and I can fill in a 1 upstairs. And that's going to leave me with that 1 up there, and this 61 over on the left. So now I can multiply those together. I've got 61 multiplied by 1 is equal to 61. So I put that down here. We subtract. 61 minus 61 is going to leave us with 0. And I can go ahead and list off, or I can go ahead and read off my final answer from looking at what we have up here. Again, a little bit awkward with that gap in the middle, but we've got a 0 down here. We don't have any more numbers to bring down, so we're done the problem. We just need to read off our answer from the top, which in this case is going to be 31. Alright, so hopefully that's making sense. It's the same process every time. On your assignment, and probably also on your test, I'm not going to give you any problems that are dealing with square roots of a number larger than 3 digits. So it'll be somewhere between 1 and 961. The next perfect square would be larger than 1,000. We won't delve into that territory just yet. I might show you guys an example of that later on, but because we haven't covered it so far, I'm not going to put anything like that on your assignment. But that's the thing with your assignment is I don't want to give you square roots that are so small that you just know them, and I don't want to give you square roots that are so big that we haven't covered them, so there might just naturally be a little bit of overlap because I'm restricting myself to such few options that I'll just pick a couple of the examples that we've done and give you a few more for you to try on the assignment, and then maybe a couple of slightly different ones for the test. But yeah, that's the basic process for calculating square roots by hand. Obviously, these things can get more complicated if you're dealing with a larger number that you want to take the square root of, or if you're dealing with a number that's not a perfect square, where your answer won't be a whole number, you don't have a zero down here. Things get more complicated, definitely, but we're trying to keep things kind of simple because this is complicated enough for the time being. Most people don't tend to know how to figure out the square root of a number by hand. People are just dependent on their calculators for an operation like that because it's not one of the ones that we commonly use. You know, we deal with addition, subtraction, multiplication, division. Yeah, sure, it's handy to know how to do those things on paper, but usually if you're working with square roots, you also aren't that far from a calculator, so you don't really need to know it necessarily to be able to get by. Yeah, so this is just something that you guys might find useful. Hopefully you're finding this helpful and not too confusing. If you have any more questions, or if you want more practice, or if you're curious to see how you would deal with the square root of a larger number, I'd be more than happy to show you that. You guys can get in touch with me for anything like that. But if not, I will get that assignment to you guys fairly soon, and I will see you in the next video. Have a good one.